Okay, so extracting metals. Really, extracting metals is all about metal reactivity. So, so really, it comes down to displacement a lot of the time, and whether or not you can do displacement. So, what is displacement? Well, if I had iron oxide and I reacted it with carbon, then I would get iron on its own plus carbon dioxide. So what's happened there is the carbon has displaced the iron because the carbon is more reactive than iron. So I'm going to just add a reactivity series so we can understand this. There we go. So this is a little way of remembering them. So anyway, the bit in bracket, the two in brackets, carbon and hydrogen, they're in brackets just because they are obviously not metals, so that's the reason why they put in brackets. So this is not a reactivity series of metals, but it's to do with metals. So you can say carbon is actually more reactive than iron. If I were to try the same trick with aluminium, so I've got some aluminium oxide, and I react it with carbon. Well, nothing happens because aluminium is up here and it's more reactive than carbon. So carbon will not displace aluminium from aluminium oxide. In fact, if you reacted aluminium with carbon dioxide, the aluminium would displace the carbon. So the more reactive element always displaces the less reactive element. So why am I even talking about iron oxide and aluminium oxide? Well, because they are what you get when you are trying to extract the metals. So the word extract, we've come across it before, but in this particular case, it's kind of you're getting metal out of something. And what are you extracting it from? What are you getting out of? You're getting it out of an ore. So what is an ore? Well, an ore is essentially a piece of rock that has enough metal in it that makes it worth extracting the metal from it. So if I get some images of some ores, I'll put them on the workspace so we can see. Here we go. Now, a rock that contains enough metal or metal compounds so that it can be mined profitably. In other words, you can actually mine it, and it's not going to be a waste of time. So I wanted to get aluminium ore if I could. Let's just I'll just type in aluminium ore, which is called bauxite, if I remember rightly. Yeah. So looks, well, I think you can get different types of bauxites, but this is an example of bauxite here that I'm about to get. So most of the time when you get these rocks that have a lot of the metal in them, they're usually going to be a metal oxide. So bauxite has got aluminium oxide in it, and then I've forgotten the name of the iron ore, but that'll have iron oxide in it. And generally speaking, if you can react it with something more reactive, then it will displace it, and then you can collect the thing that you're trying to the thing that you're trying to get. If you can't, I could react aluminium oxide with something even more reactive, so for example magnesium, calcium, sodium or potassium, but that's not really very efficient. So instead what I do is I use electrolysis. So here we go, we're talking about electrolysis. This is why electrolysis is taught within the topic of extracting metals. So we'll look at electrolysis in a little bit more detail. In fact, these bottom four subtopics are all to do with electrolysis. Redox reactions, well, briefly I'll go over redox. What is redox? It's reduction and oxidation combined. So if we look at this example here, the carbon has become carbon dioxide. It's been oxidized, and the iron oxide has become iron. It's been reduced. Reduced is the opposite, or reduction is the opposite of oxidation. However, we're going to be learning about reduction in a different way to how you normally learn about reduction. We normally think of, or oxidation as well. Normally, the clues in the name, if you say oxidation, surely it means reacting with oxygen. Well, actually, it doesn't actually mean that anymore. At least you can think about it in a way that it doesn't necessarily mean that. In fact, you can even have oxidation of oxygen or reduction of oxygen, and you can have oxidation or reduction where oxygen isn't even in the equation. So we'll try to understand what that is in a bit more detail. But that's a brief introduction, so I'll just save the video there.